The idea of protein synthesis may seem like a complex and unique process, but as you look a little closer, you begin to see connections to other things around you. One great example is a standard play in football. In this example, just like in the synthesis process, everything starts with the information. During the synthesis process, this is represented by DNA. However, in our example, this can easily be seen as the playbook. It houses all the information required for a play to take place, but the playbook itself isn't capable of performing the play by itself. In fact, the playbook doesn't even know what play the team needs to run, or how to pick a play. The same goes for the DNA of a cell. In order to make these decisions, a cell uses an enzyme known as RNA polymerase. This RNA polymerase functions just like the coach of our football team. It's his job to look through the playbook and, with the information of what his team needs, pick a play that will help them. This process of selecting a piece of DNA to be used to create a protein is known as transcription. Once the coach picks the play, he has to let his players, or the ribosomes, know what to do. For this process, your everyday cell relies upon a nucleic acid known as mRNA, or messenger RNA. Just like DNA, RNA is capable of carrying information. In this particular case, the RNA will be telling the ribosomes which protein to make. Like the cell, once the coach picks the play, he has to transcribe it so that other teams won't be able to know which play to expect. In college, you often see this as a variety of hand gestures or through a headset. This allows him to encode his message and transfer it onto the field, where the team is waiting for it. These hand signals represent the codon of an mRNA strand, as it tells the ribosome what to expect, and the quarterback's ability to read these signals represents the antigen codon, which is able to match with the codon and interpret what is going on. While the hand signals are transferred to the team, the mRNA goes to the ribosomes, where it is processed and turned into proteins, just as the coach's signals will be interpreted and turned into a play. Once the mRNA arrives at the ribosome, the tRNA, or transfer RNA, aligns with the corresponding mRNA, forming the amino acid strand. The tRNA orchestrates the creation of the amino acids. In the same way, the quarterback orchestrates his team. The coach may call the play, but the quarterback translates the signals and is in charge of passing off the football and getting the whole play started, just like the tRNA. This process of taking the hand signals and creating a play represents the genetic process of translation. After the quarterback throws the ball, his receiver catches the ball and quickly steps out of bounds to avoid a hit. When he steps out of bounds, the official's whistle blows and the play ends. The stop codon acts as the official's whistle for the ribosome. When it reaches the stop codon, it stops creating new amino acids and knows that it has successfully created a new protein.